Hello, everyone, and welcome to our online academy. My name is Alicia, and I'm very excited to be joining you today. Now, we're going to be talking about ocean exploration and finding a little bit more about how we explore our oceans. Being that we're a planet that is mostly water, mostly ocean, this is a big question for us. Now, before we get started, I wanted to invite you to explore along with us. You can text in questions today, 562-286-1838. If you are watching this after we have aired live, you're welcome to email us at live@lbaop.org. Now, I know not everyone has an opportunity to text in. That's okay. You can also write down your observations, write down your questions, email us later, tell a family friend, or look up some of this information that we're going to be sharing today. Hopefully, this sparks a little bit of curiosity and that you want to go and investigate some more yourself. Now, I'm not alone here in my studio. I have Kaya, who's putting up all of the controls behind us. Right now, we're looking at a live webcam right here at the aquarium of our tropical reef habitat. And we also have Allie, who is ready to take all of your questions today and pass those along. So I'm going to step out of the screen for just a moment here, and I want us to take a peek at this habitat, and I want us to think like scientists today. Scientists, first of all, are very curious. So as long as you're curious today, you are thinking like a scientist. And scientists just want to know more. They look for the details. And so one of the first qualities of being a good scientist is making observations. So if we were to explore this habitat, let's say you're a scientist and you found this new coral reef and you wanted to learn more about it. Let's start thinking about some of the ways that you might collect information and start maybe thinking about questions that you might want to ask and how you might explore this habitat. Now, habitats around the ocean can be very shallow, like our coral reefs, which are in that kind of top layer that get a lot of sunlight. We call that the epipelagic zone, which is epi is surface. So there is a surface level, and that's where we, in fact, find most life on our planet. As you become deeper and deeper into the ocean, it gets a little harder to explore. So I want you to think about, maybe you can text me in, why would it be harder to explore some of the deeper parts of the ocean? What are some challenges to making observations in the deep ocean or visiting those places? So I want you to think about that. We'll start in the shallow areas here and talk about exploration. But I just want you to see if anybody has some ideas that they would like to share. Or again, you can say them out loud or write them down. Now, if we were to explore this habitat here, what are some questions that we could ask? Well, we could want to know a little bit more about the organisms, the living things that make up this habitat. I see lots of living things. Do you? Yeah, there are lots of fish. There are coral, which is a living organism. And there are the non-living elements that are part of this habitat that play a huge role in how these animals live, how healthy they are, and what's available to them, what resources are available to them. So I'm talking about the water and the water quality. In fact, when we recreate these habitats here at the aquarium, water quality is a very big part in keeping our animals nice and healthy and really thinking about the chemistry that makes up our ocean. So as oceanographers, as explorers, we have to consider both of those things to really tell the story about these places in the ocean. And so some people specialize in maybe exploring some of the animals. Some people might explore a little bit more about the water itself, how it moves, currents. But really, you know, a lot of the scientists out there understand how these things are connected as well. So you may specialize in something as a scientist, but really understanding those connections paint a much larger picture since a habitat is complicated. There are many things that play a role. How do you think people explore places like this? Well, I could put some gear on and go diving. Yeah, scuba is a way to explore some of those shallower areas. I'm scuba certified. I think it's a great way, if you're older, to both do it for fun, but there's also scientific diving that happens where you can put on your gear that allows you to take oxygen and dive for a certain amount of time. Now, there are some great advantages of being in scuba gear. It's not too expensive as a scientist. You can go down and really watch animals in their habitat. It is a little bit loud as you breathe, so not all animals are great to observe while scuba diving. Sometimes the things that we're observing can be a whole study site. Sometimes they mark out areas and make observations. They can collect samples of these shallow water habitats. They can do water samples. They can record animals. They can record how clear or what we call turbid the water is, so how much stuff is floating around. So there's a lot of things that we can do as scuba divers in these shallow areas. And there's some advantages, right? That doesn't take too much to kind of put on this gear. You do have to, of course, be certified. And, you know, a lot of times you go out in teams to do this. So you have gear that basically turns you into a fish. Now, what if you wanted to make observations of animals, but you didn't want to maybe disturb the animals? And so there are other ways that you can attract animals to maybe survey animals. So sometimes we want to know how many and how many different kinds. So how many is abundance, so that's how many of a certain kind. And then the diversity is how many different kinds of animals. So there is a study, for example, called Global Fin Print that has really helped, one, with taking a look at how healthy our coral reefs are, and two, doing it in a way that doesn't involve, you know, someone having to be underwater for a really long period of time. Because remember, we said scuba is great because it's kind of easy to go down, but there is a limited amount of time that you can be underwater to make those surveys. So there is a really great program that puts a little container like this. Thank you, Miss Kaya. And there's food in here. There's snacks, right? Everyone loves snacks. Sharks love snacks. Animals down there love snacks. They can smell this food. They can't quite get to it, but it gets them over. It gets them curious. And this is a baited remote underwater video. And so it is a little contraption that they can drop in and doesn't really bother the animals, just attracts them on the reef. And they can survey, they can figure out how many different animals in a certain period of time come over. So again, they're counting how many and then how many different types of animals. And this kind of observation allows us to figure out, hey, there, and we can go ahead and play the video here. Oh, it's okay. We'll go back down and take a peek here. By the way, you can go to Global Fin Print. It's actually a nice view for us, .org, so that you can see some of these videos yourself. So this one's in the Bahamas. This is also a really cost-effective way to monitor. Now, there are volunteers all around the world that are looking at this video that's being recorded. Isn't this cool? So you're seeing different kinds of fish and animals that want, whoa, hello, shark kisses, that want snacks. Oh, here's a nurse shark. The nurse shark is going for a very different roll technique than some of the other ones. I think it's pretty sneaky. So you can see we've already actually, if you've been noticing, seeing a couple different types of sharks, not just one type. So lots of different kinds of reef sharks. Now, marine biologists that study the health of habitats like this are looking at the abundance and diversity because it tells a story. It helps, again, when considering some of the other factors in the reef, lets us know how healthy it is. So again, these are some examples of observing our oceans in these shallow habitats. So what are some of the ways that we can make observations and collect information as we go a little farther, a little deeper into our ocean? Well, you're probably thinking about, oh, cool, did you see that hammerhead? That was awesome. All right, bye, hammerhead. We've got things to talk about. So we talked about baited remote underwater, I keep on calling them vehicles, but they're video. But we can also get on to vessels, ocean-bound vessels. And there are a few organizations that specialize in ocean exploration, which is really cool. And a lot of times there are teams of scientists that study many different things, and they go on these voyages. Sometimes it's a couple of days, sometimes it's months out in sea collecting information. I think it's just absolutely incredible. So the Nautilus is part of the Ocean Exploration Trust, and they go out and they survey many different parts of our ocean. Now, they have tools that are also equipped to this vessel. So you're seeing here, this is actually, this is over 100 feet long, and there can be, their crew can range into, I think they've had anywhere from 30 plus people on these vessels. The cool thing is they can actually broadcast out and connect to scientists who are not on the ship. So even though there are scientists on board, they're also connected with scientists who maybe don't have the time to connect full time on the ship, but can help contribute to science that's happening in real time, which is really incredible. So in addition to being able to carry people out there, they have to have tools, right? Some of those tools include deploying remotely operated vehicles. Actually, in this photo, before we move on to our next one here, you can actually see the arm. Now, this is just one of 3 main organizations, and they all have very similar instruments that they can deploy. So we'll show you some examples of those. This is part of a close-up of a remotely operated vehicle. This is the arm. This is to Sebastian. You can kind of see the name here. This is for another organization called the Smith Ocean Institute, and they go out on a vessel called the Falcor, which is also very large. And they have Sebastian here who can dive down. Now, were you thinking about some of those challenges? Yeah, we talked about maybe measuring and collecting information from those deeper parts. Yeah, so as you start to get deeper and deeper into the ocean, it gets much darker because you lack sunlight. That sunlight can only penetrate down very dark. Here we go. We're going very dark. So we go down and it's cold, it's dark, and there's a whole lot of pressure. And that's because not only does the water have weight to it, but there's also pressure in our atmosphere. So they call that atmospheric pressure. Kind of like when you dive into the bottom of a pool, right? And you can start to feel that pressure in your ears. That is because you're feeling the water plus the weight of our air above us. Okay, so all of those challenges mean that we, in order to visit some of these areas, have to have instruments or tools that can withstand those elements. And those include remotely operated vehicles. Now, if you're going to go down and it's dark, you probably want to make observations, but you need light. So all of them have a capability of recording what they're seeing and also shining light. So often it kind of looks like a big robot, kind of like a big box, because it has to be very strong. Here we go. Thank you, Miss Kaya. So very strong, very enforced, and there are a lot of instruments that are kind of packed in to this very, very heavy piece of equipment. And it's so cool here too because on board they have mechanics. So maybe you're not a scientist as part of this vessel. You know, it takes a whole lot of people to help with ocean exploration. So you could be a mechanic. You could be the person who's driving the actual remotely operated vehicle, or you could be the person who is moving the arm around to take samples. So this arm has these joints in between that can move and pick up things, manipulate. There you go. So the arm can turn all the way around on this joint here. Do you see how it's kind of a round piece? It can spin all the way around 360 in order to open and close with the pincher arm here. They can also equip the arms for the remotely operated vehicles with tools to help them take samples and collect again that data that they might need. So maybe they're trying to understand the very bottom of the ocean and see what the composition of the bottom of the ocean is like, and they call that a core sample. They can do that on land as well. So taking a sample of the bottom of the ocean and seeing what kind of rocks make up the bottom of the ocean. What kind of story does that help tell about the bottom of the ocean? And so this is an image from the National Oceanic and Atmospheric Administration, or what we call NOAA for short. They're our government and federal agency that explores the ocean. So that's our third partner, our third organization that that explores the ocean here. And this is so cool. This is that arm. Again, there's someone up there, I think this is so cool, who is mechanically moving the arm. And they have this tool in the pincher area here, and they can push that with some force down into the sand or the rock or whatever tool that they need to deploy and collect a sample. You can see that the sampler here is already marked with a number, so as they come in. And then they'll put it in their little collection box, and as they come back up, sometimes thousands of feet, they will have those samples ready for them. It's so cool. So lots of engineering minds, lots of different kinds of scientists come together to make exploration happen. You can also take sample of liquids. At the very bottom of the ocean, you have sometimes those tectonic plates, right? So when we talk about kind of our core of our ocean or our planet, we have tectonic plates. Sometimes when there's movement, there's hot water that gets pushed because of all that pressure into those cracks. And because it's really hot at the core of our planet, it comes out really hot. And so they can take samples of some of this, either it's hot ocean water that has minerals as part of it, or it could even be like carbon monoxide and other gases that get compressed in and then released. It's really, really interesting. So you can see that they're taking some of these samples. Again, another image by NOAA here, the Office of Ocean Exploration. All right, so again, we've talked about some of those tools. Another thing I wanted to mention is that it is important for oceanographers, for scientists to understand the water itself. So maybe we'll go back to the picture of Sebastian as a whole here. And I think there we go. So there are devices that are part of Sebastian that also take record of the depth, so how deep we're going, the salinity, so how salty the ocean is. It's not all the same, and that helps, again, paint a bigger picture. Oh, thank you. So these containers here are on remote to open at certain depths. So again, there's a cord that's attached to the remotely operated vehicle that goes back to the vessel. And there are scientists on board in a control center who are watching that depth. And at a certain time, they can release and open these containers, which will take in water, and then they can say, okay, I have samples at, maybe 2,500 feet, which is really deep. And in that water, they can test for a whole lot. One of the really interesting things that's been coming out is environmental DNA. And environmental DNA is kind of the leftover pieces of animals. So it could be like scales that come off of a fish. It could actually be from waste, fish poop, or animal poop. So there's a lot of marine snow that happens, things that are just kind of drifting from the top. It could be leftover food pieces. Basically, there are traces of animals in the water, and they're able to analyze this water and say, who was living here? The Falcor project, so that that other organization, the Smith Ocean Institute, that has Sebastian, went out a couple years ago to study great white sharks. And one of the things that they were looking for was traces of great white sharks in their habitat. And they were using environmental or eDNA to do that because they're quite elusive. It was hard to actually find a great white shark, but they were taking samples of the water. They also wanted to investigate why sharks were coming out to a very remote part of the Pacific Ocean. And to help tell that story, they were collecting water samples. So remember in the beginning when I was talking about a combination of living and non-living things that make up an environment, the water is really important. They can even trace the amount of plankton and how much chlorophyll is in the water, which for organisms like plants, algae that use sunlight to make their food, and talk a little bit about food webs, they might want to know, okay, how much plant and algae is in the water. So lots of really cool stuff. This is just one example. There are many, many different studies out there, as well as using those cameras just to make observations as they dive deep into the ocean. They've even, oh, great. So again, as they go down, they're making observations from these control centers. And for some of those explorations, like on the Nautilus, you can watch those explorations as they happen. I think that's so cool. I think because of our current situation with COVID-19, some of those missions might be a little bit altered, but I will tell you that if you check out nautiluslive.org and you can check out some of their past expeditions, actually all three of those wonderful exploration organizations. So Nautilus Life here, again, they're broadcasting now this big satellite here to let them do that. You can see some of those explorations. You can see some of the highlights. You can see those robotic arms collecting. The Ocean Exploration Trust, Okeanos Explorer, which is the NOAA vessel here, collecting samples with those arms. It is very cool. Again, there are many ways to kind of study the ocean. So we've been talking a lot about kind of this remotely operated vehicle. And, you know, the advantages is that you don't have to have a person inside. So the amount of time that you're down at the bottom is really extended. It can be for several hours. Sometimes it's a 10 to 12 hour dive time, as they call it. And a lot of that time is actually just making their way down to the bottom or whatever site that they're studying. Not all of the teams are going to the very deepest parts of the ocean, but these are places that have had very little exploration. So I think it's really cool. The other thing that they're going to be doing is mapping our oceans. We know very little about the actual bathymetry or what the bottom of the ocean looks like. You know, as a kid, I kind of had this idea that the bottom of the ocean was flat. It was just, okay, there's the bottom, there's sand, right? That's what I can see from land. But scientists have been able to find with some really great tools that they attach to actually the bottom of their vessels, that the ocean is full of canyons, mountains, trenches, and volcanoes. In fact, that's how islands are formed, right? So there are, again, that tectonic plate motion isn't just creating these big elements on land for us. They're happening under the water in our ocean. So our tectonic plates move and shift, and they create all of these really, really interesting landscapes underwater, or the bathymetry, that bottom of the ocean. So how are we getting these images and why are they rainbow colored? So this is called a false image. And basically, this image allows us to not only see how tall things are, but because it's matched with a graph here, so red is taller, right? And you can see that even this pinkish purple color is kind of lower. It's down farther. So you're looking at height underwater. So they're coloring this because it means something. They're attaching some very specific numbers to these images. How are they getting them? Well, they're using sound. They're using multi-beam sonar. So sonar is the ability to project sound, and they're doing it in what we call a swath. It looks kind of like a big fan. And they will move the vessel. They will drive the vessel over a very specified spot. It uses sound waves to come down to the very bottom. Those sound waves bounce off of the bottom of the ocean, and information is then received and how it bounces, how fast, can tell us what is at the very bottom. And I think we might have one other image as well. So this has been incredibly helpful. Not only do we have vessels using this multi-beam sonar, which is giving us the most detailed imagery here, besides having like one of those robots, like the remotely operated vehicles. This is allowing us to take swaths of very large areas underwater. So this is really cool. The other, and then this is an image that we can talk about while we're looking for that other one. So what is the deepest part of the ocean? The Mariana Trench, the Explorer Deep. So this is an example far away. This is deployed, right? We talked about the remotely operated vehicle. This is that tether. And actually, the picture is taken by a second remotely operated vehicle that is just a little bit farther away, that provides additional light and can help with steering the up-close pieces of the ROV up close. So basically, if you're controlling the ROV that's a little farther away, you have a nice back view of the ROV from here. So they do tend to work in tandem. This is 36,000 feet is the deepest parts of the ocean. And so this isn't at the very, very deepest part, but this is exploring kind of that network, that canyon area, which is pretty incredible. All right, so we have, here's that next image. Thank you, Kaya. I wanted to show you again that the bottom of the ocean is just absolutely fascinating. This is the remnants, right, of a crater for a volcano. So at one point, there was tectonic motion that released lots and lots of energy, and basically that superheated water and magma came up and created this probably very old crater here. So the bottom of the ocean is definitely not flat. Okay, so we've talked a lot about exploring the deeper parts of our ocean. Multi-beam sonar. The last piece of equipment that I wanted to give you an example of, we've talked about remotely operated vehicles. So there's two. You can go down in a vehicle. There's manned vehicles, and I think, was it Katie Sullivan has just made a dive down to one of the deepest parts of the ocean. And that was a recent dive, and I can show you an example of what one of those manned submersibles look like on there. Kaya's going to find it for us. But again, you are limited by how much air that you have, and that's only going to be for a very short amount of time. And then the other way that we can explore that's being used a little bit more with technology are autonomous underwater vehicles. Autonomy means by themselves. So they're able to actually be deployed without being tethered to any piece of equipment on the vessel. So there's a lot of flexibility in where this piece of equipment goes, and it can be programmed to take samples with a little, like I said, with a little bit more flexibility than a remotely operated vehicle. Kathy Sullivan. So yeah, Kathy Sullivan just went down in a manned vehicle just like this, which I think is so cool. So there are still people that are going to these deeper parts, but more often we are having explorations because of those challenges by remotely operated vehicle and autonomous vehicles. We've only really just talked about a few instruments. I just want to let you know that there are many, many, many ways that scientists are exploring our oceans. And some of them, because they have interesting questions, are designing tools to meet their needs. So we've talked about some of them, but there are some very creative teams out there, again, that are multidisciplinary. So they're made up of not just scientists, not just engineers, but they have a whole team of people that come together to create things that can help them take samples or observe or just gather information and learn more about our oceans. So hopefully this has interested you to learn more about our oceans and how we explore. We have more programming this afternoon, and I hope you have a great day. Thank you so much for joining us at the Aquarium of the Pacific's Online Academy. Take care, everybody.